Hey folks, welcome to another progress report. And as you can see, we've got our VXT mounted in the place where it seems to most want to be. Got it well secured to the 2-inch main here. We've cut away some of the insulation with the customer's permission, and we reused it elsewhere on a few bare spots that the customer had, so it's all good, nothing got wasted. There's the shut-off valve that we moved the other day, backflow preventer, manual bypass. This is a isolation valve. That's a 3/8 male by female, and it goes on down there to another isolation valve because we want to make a good transition from the copper to the ferrous metal. This is our no return flush Harford loop, as you saw the other day. And this is a lovely 1 by 3/4 female by 1 sweat fitting. And there's the original copper wet return installed by others with a just simple transition fitting there, and that's all sloping down to this drain. Got a full port drain there. And ran it over to the sump pump there. And the other day, yesterday when I was taking this apart, I noticed it was pretty nasty in there, so I flushed that out before got this thing filled. It's holding water now. I've got a Street 90 there, so that barely clears the door opening. And there's the drain valve. Got some comments on this. Right now I might modify it, but I really, as you can see, we've got the Midco burner installed. Got lots of anti-seize on the surfaces of the gasket there to make it so that it is removable. Somebody wanted to see the rating plate, so let's see if I can get that. Ooh, see if you can see the. I hope that's good enough. Yeah, it's a little shiny. Sorry about that. There's the ignition module. Yeah, they're showing 2 amps is the amp draw. That's what they're showing there. And then plus, of course, the gas valve. Well, I think it's the total. It's the whole thing is about 2 amps, which isn't bad, really. Probably the whole thing 5 at most. I've never really measured it. So this is going to be modified to for quick disconnect there. I'm going to run the gas probably from here. I think I've worked it out, but I'm short a couple of lengths of pipe, so I'm going to go get that tonight. So tomorrow I should have this gas hooked up. We've worked out, Frank worked out the circuitry, so now that is nice and pure. It's only to the boiler and no other circuits tied onto it, as it should have been in the first place. So as you saw on the other video, this thing was cranked up to 9 psi. I don't know if you can read that. It's a little blurry. Yeah, it's not the best. And so I've cranked it. When I cranked it down to the 1/2 pound, what I discovered was you actually had to push down on this to get it to react. So in other words, it was the exact opposite. It was too much. It wouldn't reset. The burner would not have fired. So you want to hear that. So the pressure is supposed to push up on the diaphragm there and push up on this lever like that. And then when the pressure drops, it's supposed to turn off. But what was happening was that it was all the way up, and you had to push down on it to get it to work. Now, if this happens to you, what I would do, I mean, the proper way to do this is to take this thing apart, go down to the wholesaler where you got it from, toss that across the counter and say, I want a new one because that's defective. Well, not all of us have that kind of time, so what you do is you get in with the little flathead screwdriver and kind of tickle that a little bit, and if you go too far, then you got to sort of pry it up. So by manipulating and bending that tab back there, you're able to get this to work like that. And you just need just a little bit of pressure. But it's got to reset. See, when you let go, it should reset. That's the important thing. You want to make sure that happens before you leave the building if you're a service guy. So there we have it. Closing in on the, that's right, I got this flue collar switched over. So this is now covered, and now this is the outlet for a 4-section SGO. They can allow a 7x6 reducer, so this will be 6-inch, and then we're gonna go in there and make that work. The barometric is going to be somewhere in here, and all right. And also we've got the drip, the discharge for the relief, and a compression 3/4 male by, I guess, 7/8 or 3/4 compression. It depends. Some call it out a little differently. And then clean out there for the shmoo that is. The SGO seems to have a lot of shmoo. Every production line, even in the same company, has their own sort of secret sauce that they use to machine this stuff, and it's all different, and that's how we do it. All right, I think I've covered everything. I did. Two folks are questioning this bullhead tee. I understand why you're doing that. You definitely don't want it in water, hydronic heating. You're dealing with a non-compressible fluid. Steam is a lot less viscous and a lot more forgiving of this particular operation. If we were to bring this down to here and this down to another tee there, we'd have to crack this off, and I don't think I have enough room to put 90s here unless I rethread the pipe. So I think this is going to work. As you saw the other one, when you saw the initial video of this series, you saw that they had fed 2-inch in there, and that was heating the building. Customer said even with a hole in the boiler, the radiators got hot, sort of, not that great. I think on this one here, I think this is going to work okay, considering the sizes. And I would do say that this is pretty much by the book here. That's the only thing that might be, purists might have a question on it. But I appreciate the comment that when you're in the basement, you got to do what you got to do. So, signing off now. Stay safe, everybody. Thank you for your comments and your questions. And Hope to give you another progress tomorrow.